All right, let's dive into one of the most mind-bending topics in the entire universe, black holes. These things are the ultimate mystery, right? They push our understanding of space, time, and, well, reality itself to the absolute limit. So let's take a journey. So, what exactly are we talking about here? This definition really nails it. I mean, think about gravity, but turn the dial up to a billion. It's a force so incredibly powerful that once you're too close, nothing can get away. Not even light, the fastest thing we know of. And that, right there, is why they're black. They literally can't reflect anything. That's the big question, isn't it? I mean, things like this don't just pop into existence. You need something truly epic, a cosmic event of unbelievable power, to forge an object with that much gravitational pull. So, how does one of these monsters get made? To understand how a black hole is born, we have to start with the death of a giant. We're going to go back and witness the final spectacular moments in the life of a really, really massive star. This is where the whole story begins. You can think of a star's entire life as this constant, massive battle. Deep in its core, you've got nuclear fusion pushing outwards, fighting against the crushing inward pull of its own gravity. And for millions of years, it's a perfect balance. But for the biggest stars, that fuel eventually runs out. That outward push just stops. And gravity, which is always there, always pulling, it finally wins. And it wins in the most catastrophic way imaginable. So, at the very center of that collapse, something absolutely wild happens. All of that star's matter gets squeezed down into a point that is so small, it's basically zero size, but with a density that is literally infinite. We call this the singularity. And here's the kicker. This is the point where everything we know, all our laws of physics, they just break. They stop making sense. It is the ultimate unknown. Okay, so we've made a black hole. Now, let's do something a little crazy. Let's get closer. What would it actually be like to approach the edge of one of these things? Because this is where reality starts to get really, really strange. This is probably the most famous part of a black hole, right? The event horizon. Now, it's not a physical surface. You couldn't touch it or land on it. It's more like an invisible boundary line drawn in the fabric of space-time. And once you cross it, there is absolutely no coming back. Ever. Now here's where your brain might start to hurt a little bit, but this is so cool. It all depends on your point of view. If you stayed a safe distance away and watched your friend fall in, you would see them get slower and slower as they got close to the edge. They'd look like they were frozen in time, right before fading from view. But for your friend, for them, they just sail right across that line without feeling a thing. Two totally different realities happening at the exact same time. So wait a minute, how can two people witness the exact same event in two completely different ways? What points to something really deep. It means that one of the most fundamental things in the universe, time itself, is being bent and twisted by all of this gravity. And this is the result. It's called gravitational time dilation. The stronger the gravity, the slower time flows. So if you could somehow hover just outside the event horizon and then return, you'd find you've aged only a little, while centuries or even millennia could have passed for everyone else. You would literally see the future of the universe unfolding in fast forward. We've hovered at the edge, but now it's time to take the final plunge. What actually happens if you cross that point of no return? Well, this is where our journey goes from strange to genuinely terrifying. It has a strangely playful, almost silly-sounding name for what happens next: spaghettification. But let me tell you, there is absolutely nothing funny about it. This is maybe the most brutal way to go in the entire cosmos. Here's how it works. The pull of gravity would be so much stronger on the parts of your body closer to the black hole, say your feet, than on the parts farther away, like your head. This difference in force would stretch you. It would literally stretch you vertically while squeezing you horizontally until you were just a long, thin stream of atoms. Just like a noodle. Now, interestingly, the size of the black hole actually matters here. If you fell toward a smaller one, you'd get spaghettified before you even cross the event horizon. But the giants, the supermassive black holes at the center of galaxies, their tidal forces are much gentler at the edge. You could actually cross the event horizon completely intact. Of course, your doom is still inevitable, just a little later on. But yeah, escape, still totally impossible. See, once you're inside, the very rules of the universe get flipped on their head. Space and time essentially swap roles. The singularity at the center is no longer a place you can avoid. It becomes an event in your future. Moving forward in time now means moving closer to the center. Every single possible path you could take, no matter which direction you try to go, leads you straight to it. Okay, that was pretty intense. After a journey like that, it's really easy to just think of black holes as cosmic monsters, right? As pure agents of destruction. But is that the whole story? Let's pull back and look at the bigger picture. So we have to bust a pretty common myth. The idea that black holes are like cosmic vacuum cleaners, just roaming around and sucking everything up. That's not really how it works. They follow the laws of gravity just like a star or a planet. You have to get really, really close to be in any danger. In fact, far from just being destroyers, scientists now believe they are absolutely essential builders in the universe. And this really reframes the entire narrative, doesn't it? The thinking now is that those supermassive black holes that we see at the heart of nearly every galaxy, including our very own Milky Way, are fundamental to how those galaxies formed in the first place. They aren't just destroyers, they're more like cosmic architects, shaping the universe on the grandest scales. And that brings us to the final, tantalizing question, the one everyone asks. Could we ever travel through a black hole? I mean, science fiction loves the idea of them being wormholes, right? Gateways to other places, other times. But based on the physics we know today, it's a one-way ticket to oblivion. And yet, the fact that all our science breaks down at the center, that leaves just a little bit of room for wonder, doesn't it? It's a powerful reminder that the universe's biggest secrets are still out there, just waiting for us to figure them out.